Okay, so today we are looking at the area of non-right angled triangles and area of a segment as well. Now, first of all, let me talk to you about what the area of a non-right angled triangle is. We'll talk about a segment in a bit. So get down the title, area of a non-right angled triangle and segment. So let's just draw a triangle first of all. So here's a triangle. Now the formula for the area of a non-right angled triangle is equal to a half AB sine of C. Half AB sine C. Now it doesn't matter. The A and B can be anywhere. Now I'm just going to put a little note on this because the A and B stand for any two sides as long as C is the angle in the middle. So this is any two sides as long as this is the angle in the middle. So it's any two sides and C is the angle in the middle. So it doesn't matter which one I call it. If I say this one is A and this one is B, then the angle must be that one, capital C. I could also say that this one was A and this one was B, so in which case the angle in the middle would be C there. But because we're doing our diagram, I'm just going to do A and B, and this is our angle here, which is C. So this is the formula for a non-right angled triangle. Really straightforward. Okay, so let's go with this first question then. This one here is example 1. So it's any two sides and the angle in the middle. So hopefully we've drew this down. So it's always worth writing down the formula in case we need to work backwards. So my area is equal to a half AB sine of C, like so. Now, A in this case are the two sides and the angle in the middle. So the formula for this, the area is equal to a half times by, well, let's pick the left-hand side first, times by 4, times by 3, times by sine of 69. So, fraction 1 over 2, you could put 0.5 if you wanted to. A half times by 4 times by 3 sine of 69 is equal to the area, which is equal to 5.6 centimeters squared to 1 decimal place. Nice and straightforward, that is. Oops. Okay, so if you've got that one down, have a go at the one on the right-hand side. Have a go at this one on the right, nice and straightforward, and once you've got your answer, pop it in the chat. Some people have got it already. Super. I'll quickly go through it then. So my area is equal to a half AB sine of C. So we know that the area is equal to a half times by 3 times by, oops, nearly said 4 then, 11 sine of 46, which is equal to 11.9 centimeters squared. Brilliant to everyone who's got that right. Spot on. Super. All right, so let's move on a little. Let's move on. And we're going to move on to a segment. Now, first of all, let's just draw what a segment looks like. So if I've got a circle here, a segment is this part here. So this is called a segment. Now we're going to use two things we've been using recently, because if I want to find the area of a segment, it's the area of this sector here. So it's the full area of the sector take away the area of this non-right angle triangle. Now don't forget, we're usually given what this angle is here. It's called theta. And these two sides here, because they're coming from the center, these are both radius or radii. So the area of a segment is equal to the area of a non-right angled triangle. I said that wrong, sorry. It should be the area of my sector subtract the area of the non-right angle triangle. So we've got the area of this sector here, which is this red part, take away the area of this non-right angle triangle, there like so, which gives me the area of this shaded part here, this black part. So maybe I'll draw that out. So here's the sector, and here is the non-right angle triangle. And if you want, maybe you can just underline that one there, and underline that one there. So let's have a go at one of these questions then. Here it is. So this one here would be example 2 on our book. It's example 1 for segments, but seeing as though we wrote the title as triangles and segments. We'll do example 2. To get this one down, they're asking us now to 3 significant figures. Make sure we've got that. So we know the area of this shaded bit is the area of the sector, which we worked out before. Take away the area of the non-right angle triangle. Now, the first thing that I'm going to do with this is I'm going to label that other side. Because this here is a sector, or an arc of a circle, we also know that from this O to B is also 10 centimetres, because they are both radius. So you've got a radius on one side, you've got a radius on the other side. So let's first of all work out the area of the sector, which is equal to, well, we know the area of a sector is theta over 360 times by pi r squared, which in this case theta is 95 over 360 times by, now let's just write on the side here, my radius is equal to 10 centimetres, my diameter is equal to 20 centimetres. So times by pi times by 10 squared. Let's get our calculator up. So we've got fraction button first, 95 over 360 times by shift pi times by 10 squared. So the area of that sector, I'm going to write it to 3 decimal places, and I'll think about the significant figures later. I might need to come back to that. So it's going to be equal to, in fact, what is it as a, yeah, I'll write it in terms of pi because it's more accurate. 475 over 18 pi centimetres squared. So there's the area of the sector. We also need the area of the triangle, the non-right angle triangle. Now, this is going to be 2 sides with the angle in the middle. So in this case, it's going to be the 10 and 10 with this 95 in the middle. So the area of the triangle is equal to a half AB sine of C, which is equal to a half times by 10 times by 10 sine of 95. Let's get that in our calculator. 0.5 times by 10 times by 10 sine of 95, which is equal to 49.809. So the last little part to find the segment is to take away the area of the sector, which is this part here, subtract the area of the non-right angle triangle, which makes sense. Make sure I've got my units on that. So it's going to be 475 over 18 pi minus 49.809. So 475 over 18 pi subtract 49.809. Let's write it as a decimal. We said we want it to, let's write it out completely and then we'll round at the end. So 32.5705 centimeters squared. So to 3 significant figures, I'm going to put that there. It's going to be equal to 32.6 centimeters squared. Brilliant. Super. All right. So have a little go at that one on the right hand side. Make sure that example 2 is down, and then have a little go at that one on the right. Okay, so let's start having a little go at this. So we'd need the area of the sector first. Which is equal to theta over 360 times by pi times by r squared, which is equal to 62 over 360 times by pi times by 5 squared. Let's just quickly work out what that is. So 62 over 360 times by pi times by 5 squared is equal to 13.526 continued on. So the area of the triangle is equal to a half AB sine of C. Remember, it's the two angles with the side in the middle, which is equal to 0.5 times by 5 times by 5 sine of 62, which is 11.036.8. So then I need to subtract those. So it's going to be 13.526, 13.526, subtract 11.0368, which is equal to three significant figures now. So all of that, I should write that down. So 13.526 minus 11.0368 is equal to 2.4892. So to three significant figures, that's going to be equal to 2.49 centimeters squared. Okay, be careful with your rounding there. Okay, hopefully you got that right. So here we've got a GCSE question. I thought I'd just show you that they do come up. Can you have a little go at this one yourself? Have a little go at this one yourself. Okay, I can see that some people are finishing now. So let's have a little go then. So the area of the sector is going to be equal to 120 over 360 times by pi times by 10.4 squared. Let's get up our calculator. So 120 over 360 times by shift pi times by 10.4 squared is equal to 113. So we want 3 significant. I'm going to do a few decimal places. 113.265 centimeters squared. So the area of the triangle is equal to a half times by 10.4 times by 10.4 sine of 120. So 0.5 times by 10.4 times by 10.4. I could square that if I wanted to. Sine of 120 is equal to 46.8347 centimeters squared. So now when I subtract these, it's going to be 113.265 minus 46.8347. So 113.265 minus 46.8347 is equal to 4 marks. So that's equal to 66.4303. So to 3 significant figures, it's going to be equal to 66.4 centimeters squared. Brilliant. Super. So there's that one done. Now I've put this one on here because it's a little bit trickier, but it's almost like exactly the same as the last one. There's just one extra step in this. Now this came up on the IGCSE in 2012. I thought it was a great question. There's just one little extra step here. So if you're doing this yourself, maybe have a little go at it. Maybe give yourself a second to have a look at it, and if you want to start having a go at it, and I'm going to go through in a second. Okay, I'm going to start going through it, so make sure you get this one down. This one is example, I think this one is example 3. Definitely get this one down in your notes. I think it's a good one to have a look at. Now, the thing that people always forget is the fact that these are all radius or radii. I need to figure out which word that is, okay? So what that means is that this here is the same as this length, is the same as this length. So, the problem at the moment you've got is that you've got no angles in that triangle on the left, the 9-9 triangle that's making the sector. However, I have got a triangle in this one on the right. So, because these two here are radius, it means that this triangle here is an isosceles triangle, which means that I know that this angle here is also equal to 35 degrees. and then you're off. As soon as you know that this is an isosceles triangle, you can start to really fill everything in. So if that's 35 and that's 35, then I know that I can take these away from 180. So 180 take away 35, take away 35. Well, 35 and 35 is 70. So 180 take away 35 is going to be equal to 110 there. This on the left is angles on a straight line. So this here is equal to 70. And then you've got that angle in the middle, haven't you? So we've used everything we know to find out what that angle on the left-hand side is. And then you just do exactly the same as you would normally. Now notice this is 6 marks. There's an extra 2 marks for that little part there. So the area of the sector is going to be equal to 70 over 3 squared, which is equal to 49.48 centimeters squared. Then we've got the triangle, which is going to be equal to 1/2 times by 9 times by 9 sine of C, which we know is 70. So 1 over 2, 1/2 times by 9 times by 9 sine of 70, which is equal to 38.058. Then we're going to subtract both of these, 49.48 minus 38.058. 49.48. 49.48 minus 38.058, which is 11.4 centimeters squared to 3 significant figures. Brilliant. Super. All right. Now we've got a couple more questions to have a go at before we have a go at our worksheet. So we've got this one here. So this one here I will go through because it is tricky. This one here is example, what was it, example 5, is it? Example 4. Now this one here is one of those questions that we always come across where we're working backwards, okay? It's not too difficult, I don't think, if we know how to work backwards, but we do need to, there's one little part that we might not have seen before in this one. So, we now know that the area is 15. It's telling us it's an acute angle, but we also know that the sides are 7 centimeters and 5 centimeters there. So if I want to find out my angle in the middle, we know that we're going to be using the area of our non-right angle triangle. Okay, so the area of a non-right angle triangle, we know that the area is equal to 1/2 AB sine of C or sine of theta. It's up to you. Brilliant. So we need to follow those steps, don't we? We write down the formula, we substitute in what we know, we simplify, and then we work backwards. So I know that the area is 15, I know the sides are 7 and 5, so let's substitute in everything I know. So it's going to be 15 is equal to 1/2 times by 7 times by 5 sine of C, which in this case is theta. So I've wrote down my formula, I've substituted in, now I need to simplify. Now the part that I can simplify is the 1/2, 7 and 5. Because 0.5 we know that 0.5 times by 7 times by 5 is equal to 17.5. So I can simplify this part here, because that is a number. So this is equal to 15 is equal to 7.5 sine of theta. So to get rid of that 17.5, I need to divide by 17.5 and divide by 17.5. So 15 divided by 17.5 is equal to, well, this is equal to 0.8571428 6 is equal to sine of theta. Now this last part is the part you might not have seen before. If you've done some trigonometry of right angle triangles, or you've done normal trigonometry, then you might have seen this before. The problem is we need to get rid of that sine, don't we, to get the theta on its own. However, the issue is you can't just divide by sine. The inverse of sine is sine to the minus 1. That's how we do this. So we're trying to find, so this is what we're doing. We're going to be doing sine to the minus 1 of this number here, so 0.8571428 is equal to theta. That's how we get rid of that sine on the right-hand side. So with this one here, now on my calculator, the way I'm going to do this is I'm going to go, you've got to press, you know, it's the sine to the minus 1 is above the, just slightly above the sign. So I've got to press shift, sine to the minus 1, which is there, which is above it. And I want sine to the minus 1 of my previous answer. So I'm going to put answer in there. And they want this to correct to 3 significant figures. So theta is equal to 58 point... I've got a problem, haven't I? Because it's going to round up that 9. So it's going to be 59.0 there, degrees. Super. Okay. We've got one more question to go through. Okay, so let's move on to the last question. And this one here is a little bit trickier. We're starting to use a bit of algebra here. So this one here says determine the area. So this one here was example 5. Example 5, our last example. So the area of the following triangle is A. Determine the exact value of x in terms of A. Now, sometimes this will come up on a non-calculator because you're expected to know some of these sine values, but I'll show you how to do it. So we're talking about the area of a non-right angle triangle. It's asking for it in terms of x, and it wants the area. Sorry, it's asking for the area in terms of A. Sorry, it's asking for x in terms of the area. So we know that we're going to be using the formula for the area, which is area is equal to a half AB sine of C, which is the angle in the middle. So I'm going to substitute in all the things I know. Now, I'm just going to write them down to make it really clear. I know that my area, they've given it as A there. I know that A, well, it doesn't matter which one's A and B, but we're going to say that A is X, which is the top one, and B is the bottom one, which is X, and C, which is my theta, which is 45. So let's sub all of that in. So this is going to be A is equal to a half times by X times by X times by sine of 45. So it's exactly the same as what we did usually. We write down the formula, we sub in what we know, we simplify, and then we work backwards to find out what we want. Now, we want x, but it's in terms of a. So the next stage I need to do is to simplify. Now, there's only two things I can simplify. I can simplify this half here and the sine 45, because they are both numbers. Half and sine 45 are both numbers. So I know that sine of 45 sine of 45. Now, we want that. Now, the problem here, there you go, sorry. The problem we've got here is we want this as an exact value. So they've given us a decimal here, but sine of 45 is actually a surd. We can write this as a surd. It's one of the ones you need to know. So sine of 45, they wrote it here as 1 over root 2. But actually, sine of 45, now you'll need to know this. This is something you might not have done before. Sine of 45 is equal to root 2 over 2. That's something you'll need to know. So a is equal to, well, it's going to be a half. Now, x times x is going to be x squared. So let's put x there. Times by sine of 45, which we know is root 2 over 2. We know that. So this is equal to, now I need to times that number. So it's going to be 1 times by root 2, which is root 2. 2 times by 2 on the bottom is going to be 4. And this is times by x squared. Okay, we're getting there now. So to get x on its own, I need to first of all times by 4, which is going to be 4, let's write it down just so we know, times by 4, times by 4. So we know that if we times by 4, we get 4a is equal to root 2 x squared. Then we need to get rid of that root 2 by dividing by, divide by root 2, divide by root 2. So we end up with 4a over root 2 is equal to x squared. And then the last little stage, I need to square root both sides. So it's going to be the square root of 4a over root 2 is equal to x. Now, they might have actually rationalized at this point. I might even do that. So rationalize the surd. So times the top and bottom by root 2. It is tricky, this one. There's a lot here that we're taking in. There's a lot kind of extra that we need to know. So to rationalize this, it's going to be 4 root 2a over 2 is equal to x squared. That 4 and 2 is going to cancel there. So this is going to be equal to 2 root 2a. So I end up with 2 root 2a is equal to x squared once I've rationalized it. And then square root all of that. So it's the square root of 2 root 2a is equal to x. Now, it's tough, that. It is tough. Don't worry too much if you're struggling with that one, because I think that one's tough. Let's just check the answer for that one. So there's the answer for that. Brilliant. Okay, so these are the questions we're going to have a go at now. So if you're catching up at home, pause now and have a little go at those ones. And if you're catching up from home, we've got the second part here, so pause now and have a go at those ones. And there's your answers to those if you're catching up at home. Brilliant. So thank